All right, let's jump right in. Today, we're going to pull back the curtain on one of the coolest concepts in machine learning, the support vector machine, or SVM for short. What is this thing, and how does it work? Let's get into it.
It really all boils down to a pretty simple question. Let's say you've got a camera roll full of pet pictures. Some are cats, some are dogs. How would you teach a computer to tell the difference? This is a classic classification problem, and it's exactly what SVMs were born to solve.
So, yeah, we're talking about the fundamental challenge of classification. It's not just about animals, right? It could be filtering spam out of your inbox or even trying to predict if a stock is going to go up or down. The core task is always the same. Teach a machine how to put new information into the right bucket. To make this happen, we have to turn each object, like a photo, into a point on a graph. The location of that point is determined by its features. For a picture, features could be anything like the average color, the texture of the fur, maybe the pointiness of the ears. The machine's job is to look at all these points and find a pattern. And this is where the support vector machine makes its grand entrance. It's a really powerful, but honestly beautifully simple way to tackle this classification problem. Its whole purpose in life is to find the absolute best dividing line to split our categories. Now, the official fancy name for this dividing line is a hyperplane. But don't let that term intimidate you. Seriously. If your data only has 2 features, the hyperplane is just a straight line. If you have 3 features, it's a flat plane, like a sheet of paper. It's just the separator. And this visual just makes it all click. Take a look. You've got your blue cat data points on one side and the green dog data points on the other. The SVM's job is to draw that orange line, the separating hyperplane, smack dab in the middle. Simple as that. Anything that lands on one side is a cat, anything on the other is a dog.
But wait a second. That's the big question, isn't it? I mean, you could draw a whole bunch of different lines that separate those two groups. So how does the SVM figure out which one is the absolute best, the most reliable choice?
And this right here is where the real genius of the SVM shines through. It isn't just about finding any line, it's about finding the optimal line. The secret sauce involves 2 key ideas: margins and support vectors.
First, let's talk about the margin. Think of it like a buffer zone or a no man's land around our dividing line. It's the empty space between the hyperplane and the closest data point from either side. The whole goal of an SVM is to make this margin as wide as it can possibly be. Why? Because a wider margin means our model is more confident.
So what defines the edges of this buffer zone? Well, those are the support vectors. They are the most important data points in the whole set because they're the ones sitting right on the edge of the margin. They literally support the position of the hyperplane. If you were to nudge one of those points, the entire dividing line would have to move.
Let's go back to our graphic because it shows this perfectly. You can see the whole system in action. The SVM has found the line that creates the biggest possible margin, that big empty street between the 2 neighborhoods. And you see those 2 points, one blue cat, one green dog, that are just touching the edges of that margin? Bam! Those are our support vectors. Now, it's super important to remember that this is a supervised learning technique. The machine can't just invent this from scratch. We have to give it a training set first, a bunch of data where we've already labeled which pictures are cats and which are dogs. The SVM learns from our examples to figure out where that perfect boundaries should go. Okay. So this all works great when your data is nice and neat and you can split it with a straight line. But what happens when things get messy? Like they always do in the real world. And that really lays out the biggest hurdle for SVNs. They are champs when it comes to what we call linearly separable data, stuff you can divide with a ruler. The problem is most real-world data isn't so clean. A lot of the time, the cats and dogs are all mixed together, and you just can't draw a simple straight line between them. The solution for this is a brilliant piece of mathematical magic known as the kernel trick. Now, we're not going to get lost in the math, but the basic idea is that the kernel trick cleverly projects the data into a higher dimension. It's like looking at the problem from a new angle, where you actually can draw a clean line, or plane, to separate them. It's how SVMs handle really complex, tangled-up patterns. So now that we have a feel for how it works, where is this technology actually being used? Well, it turns out it's powering a lot of things you probably use every single day. Let's think about it. Ever used your face to unlock your phone? That could very well be an SVM at work. What about the spam filter in your email that saves you from a ton of junk? Yep, an SVM is probably in there, classifying messages as spam or not spam. Even systems that can read handwriting often rely on this powerful method. And that quote really just nails it. For all their power, at their heart, SVMs are loved because they're so simple and elegant. They solve a complex problem by just focusing on finding the widest road between two groups, defined only by the most critical data points, our support vectors.
So I'll just leave you with this question to chew on. Now that you get the core idea, find the biggest possible gap between two sets of data. What other tricky sorting problems do you think an SVM could solve? Maybe diagnosing diseases from medical scans, or predicting which customers might be interested in a product? The possibilities are pretty much endless.
And this is really just one piece of a much larger puzzle. If this stuff fascinates you, the world of AI has so much more, from how these models are built to how to design amazing products with them. And if you want to keep up with all the latest in AI strategy, the AI Product Management Playbook is a fantastic place to connect with other pros and just keep that learning going. Thanks for tuning in to this explainer.